And then Jen, you can just start sharing and go ahead, and I'll be admitting more people into the room as they come.
All right, cool. Thanks very much. I'm going to be dropping a link in the chat to one of the tools that I'll be using today. This is a vector calculator that I've developed. There we go. So there's a couple different ways that theorists have looked at pitches using Fourier space, but today we're just going to kind of look at the 12 pitch classes. The DFT basically breaks down a signal into its constituent cyclical components. In the case of pitch classes, this basically is equivalent to its interval cycles. The 6 cycles are roughly correlated with the 6 Fourier components. These components give an indication as to what sort of harmonic flavor is being expressed. So does it sound really fifthly, or does it sound major thirdish? The combinations of all the components or individual flavors is what helps make up the sonic landscape, at least from a pitched perspective. I'm not touching rhythm or any of the other many things that make music sound like music, just pitch classes today. And the DFT helps us separate out those different flavors and to see the underlying recipe. So first, I want to take a look at those 6 components. Should be sharing screen. So this tool is built off of Ian's metaphor of the Fourier balance. We can plot vectors on the calculator by adding pitch classes on the left. So if I wanted to add the C major diatonic collection, every time I add a pitch class on the left, we see a vector drawn pointing to that pitch class's position in the diagram on the right. So just kind of go through, plop all these guys in. And there's our C major diatonic collection. So what we're actually interested in is the total amount of tilt and the direction of that tilt. So when we calculate, turns out diatonic collection is not very chromatically clustered, which is what the F1 Fourier component is showing us. Versus, say, if I scroll through to the F5 component, very clustered on the circle of fifths, which is what F5 is showing us, we get a much larger resultant vector shown in green. All the red arrows there are the original vectors just kind of added together, positioned head to tail, which shows us the total amount of tilt. With this tool, I can also handle multi-sets. So say if I wanted to look at the voicing of a particular chord, we've got, let's say we have 3 pitch class zeros. We've got 4 of those, and no pitch class 4, and just kind of changing things up. So probably some sort of 2/7-ish kind of chord going on here. So very, very different magnitude or amount of tilt, in this case 5.87, and phase the direction. And this, what the DFT does is it gives us the information for all 6 of the Fourier components. So if we back to F4, F5, F3, go back to F2, and F1. So this is basically just a visualization tool of the idea of the Fourier balance. Now, to look at actual music, I wrote a little program that I'm using for my research. Let me pull it up here. A Panorama Generator. This is looking a little clunky right now, but there's a version that's going to be up on my website within a month or 2 that's going to look a whole lot nicer. This is fairly utilitarian. So I've got, let's look at Mozart Dissonance K465. So this is going to be just the exposition of Mozart's Dissonance Quartet. We'll look at the entire exposition. So the way that this works, the way I generate these panoramas is by creating a sliding window. Let's make this one 12 beats long. And what it will do is perform the DFT on all of the pitch class information within that window, and then slide on to by a beat, do it again, and slide on until we get to the end of the piece. We can count pitch classes based on how many onsets there were, based on the total duration, or just a flat set of a binary, is the pitch class present or not. I'm using a logarithmic weighting system. This can also handle quarter tone music, but since it's Mozart, I'm going to keep the EDO at 12, not 24. And then we calculate, and wait a moment, it has to think, as one does. There we go. Then we can go and take a look at the data. So first, let's look at just all 6 magnitudes. So what we've got here is all 6 magnitudes for just the exposition. So with the Dissonance Quartet, if you recall, there's that slow introduction that's very, very chromatic. So at the very beginning, we see this little jut of blue up here. That represents the F1 magnitude, or the chromatic clustering. That shows us that slow introduction. The allegro picks up, and suddenly purple dominates. Purple is the F5, or the measure of diatonicity. Turns out that most of the music is diatonic until we get to this transition section where it suddenly dips down quite a bit, but then comes back. We could look at the table. This has all the raw numeric data that's being used to generate this this graph. We can look at the original array. So what this is showing us is that there are 15 Cs, or pitch class 0. There's 1 pitch class 1 for pitch class 2s, and so on down the line. And so we've got all of this information for the entire excerpt that we're looking at. We could look at individual components. For example, taking a look at F5, update the graph, update the table. There's our measure of diatonicity throughout, and then overlaid is the phase, or the direction that the tilt is going. In the F5 component, this can roughly correlate with implied key signature. So what we can see here, we can actually see the modulation to the dominant. It's roughly hanging out around 60 degrees, and then juts up and is hanging out around 90 degrees for the rest of the time. Yeah, so I'm happy to keep kind of tinkering around, showing different aspects of the program and the DFT. Basically, a lot of what I do is stare at graphs and find things that look interesting, and then look at the music and see what's going on there, or stare at numbers and see if any of them jump out at me.
I have a quick little request.
Please.
Could you show the phase of F3 for this example you're looking at?
Yep.
So what I wonder is there when you go from 180 to minus 180, because of the line graphing.
Yeah, it looks super dramatic.
Yeah. So that's the hard part to solve because actually if it's more complicated, then you can kind of figure this one out, but you really would like to get show it actually the cyclic nature of the phase.
Right. Do you have any suggestions how to represent that a little easier? Because there's going to be a split somewhere, even if I go from 0 to 360.
Yeah, there has to be a split, right? But you can, I think, one way is just to have it kind of go up to the top and then kind of jump down to the bottom, but without having a line from top to bottom.
Oh, I see what you're saying. Okay. Yeah. Right. For F6, what I did, let's see if it's doing it right. I changed, because sometimes just for whatever reason, sometimes it was negative 180, sometimes it was 180. I changed it to always be 180, and that kind of smoothed this one out. But I
Yeah, rounding
couldn't
error.
really do that for all of the
Yeah.
other components.
Yeah, phase is not really meaningful for like F6 is basically one dimensional. You just want to look at the real value of it. Yeah.
Right. Right. Yeah.
This is really cool stuff, by the way.
Thanks.
Yeah. I like that the calculator looks really great.
Thank you.
Is there a reason why you chose to put the pitch classes where you did? They're like somewhere around like 3 or 4 units out in the circle.
That's so I believe the way it's set up, yeah, I think it's 3 units out, and then any more than that, it starts shrinking. So 5, it's not going up by the same amount. That's more just kind of to show proportion.
That's the logarithmic weighting.
Yeah.
Yeah.
And I can take that off and just do linear weighting. There we go. But they're still proportional without going outside the image too much.
I had a quick question. First of all, this is awesome, Jen. This like that visual vector calculator is sick.
Thanks.
Was the XML files, are we allowed to, can we put in our own, or is this on your website? Can we like drop XML or humdrum files?
Right. So the goal is that you can upload your own XML, humdrum, kern, anything that Music 21 can read will be able to be read by once it gets put up online. So right now the program is just drawing from my own hard drive, but I'm working on a little database of provided scores plus allowing a space for people to upload. I'm not sure how long it will take to get the uploading mechanism up and working, but that's the goal.
Awesome, thanks for that. Also for the phase, rather than represent absolute phase, you could represent the distance from one to the next. Therefore, when it's wrapping around, it would show like a small unit rather than the leap down.
Sure. Yeah. Thank you.
Ian asks what tools you use to make these web apps.
This is written in JavaScript, and the website as a whole is in Flask and Elm.